So now in this video we're going to look at the 7805 integrated circuit component. What it is, it's a 7800 series positive voltage regulator. We're using positive voltages here in relationship to ground. There's a 7900 series where the voltages are negative in relationship to ground. But in any case, the last two numbers there give you the voltage that you'll be getting at the output. So this will be 5 volts. As you can see, 5 volts there. The capacitors just help stabilize things for the most part. So you can use a slightly larger value capacitors or whatnot. And a lot of circuits you may get away without having them at all. But the data sheet shows that you got a 0.33 microfarad from the supply voltage there to the common pin and ground. You got common in the middle pin there. And then 0.1 microfarad from the output pin to common. And so this side is more positive. If the capacitor is polarized, make sure you put the positive side to those two inputs there. So in any case, the data sheet that I used was the UA7805. I think it was Texas Instrument data sheet. There's also the LM7805, and the component I have just says L on it. So those should all be the manufacturer. And so they should all have the same values though, for the most part. So the supply voltage recommended, these are recommended values, is 7 to 25 volts. So I think the absolute maximum is 35 volts, but recommended maximum is 25 volts. And then maximum current, this was still in the recommended area, was 1.5 amps. So they didn't write this, but I'm going to add, you would need a large heat sink for that. And so additional to that, there's internal thermal overload protection. So as I said, if you don't use a big enough heat sink for whatever you are demanding of it, the amount of current, the 7805 actually starts limiting current. It really does that by dropping voltage so that there's less voltage for the load, and the load will probably limit current. Otherwise it limits current as needed to keep it from overheating, because all of this voltage that's coming in, when it gets converted to lower current in order to lower the voltage there, then it creates heat. And so the less current it lets through, the less heat that it builds up, and the cooler it stays. So it does that internally. You don't really have to worry about burning these out, although you probably shouldn't push it too hard. So we'll look at the circuit on the board, not that complicated. The left pin is the output, middle pin is common, and then the pin to the left there is the input pin. So if I swivel it this way, now the input pin is on top. And so we'll put that to the positive supply up there. The common pin we're putting to ground. You can see we got a capacitor from in to common. And then we got another little capacitor. We could probably get rid of these, it would work just fine. But in case, we got the other capacitor from ground to the output pin. And there we go. Right now I have the power supply set to 7 volts and the LED is getting 5 volts. Here you can see that the power supply is set to 5 volts. There's about 15 milliamps of current flowing through the circuit. So that will mostly be set by, almost completely, by the resistor and the LED having 5 volts across them. We're going to keep raising this. So it was probably just borderline 16 milliamps. Barely went up. And you can see I'm going to go up to 25 volts. And we got about the same amount of current flowing through there as we did with 7 volts. But of course we should really measure the voltage with the multimeter. This is auto ranging. I just have to set it to voltage. Red probe stays there for everything but high current. This is a really easy to use meter. We will first look at the supply voltage and see that we are indeed at 25 volts, falling just a speck shy. And then we come down to either the resistor directly or to the terminal of the integrated circuit there. And there you can see we got 5 volts. So a speck shy, but pretty much spot on 5 volts. So really, that's about it. It outputs 5 volts. We should lower the voltage of the power supply because I might wire something up thinking that this is at 5 volts when it was really at 25 volts. So now we're a little shy. This is going to lose a little bit of power. That might be pretty hot now since we had 25 volts. So I'm not going to touch that for a while. But make sure you turn the meter off when you're done. And I'm going to turn the power supply off. Make sure that cools off before I pull it out of the board. So in any case, That's it for this video. Hope you enjoyed. Make sure you check out one of the other videos I'm posting to the screen. Click like, subscribe, the bell, all that. Donate to Patreon if you can. That helps out the most. I have links down in the description. But watching videos helps out a ton. I really appreciate you watching them. I'll see you in the next video.